This is an interesting problem taken from Mannering and Washburn book on Intro to Highway Engineering 5th edition. So in this problem, you are required to find out the car weight necessary to overcome the track to resistance. Track to resistance, of course, is a combination of aerodynamic resistance, rolling resistance, and grade resistance. So what they have done is, it's though it is not common, people forgetting track to resistance. Maybe you want to pause the video, read the problem, and pick up from this point as I explain the problem. So the weight of the car, they already have weighted at 2,500 pounds, and the car is designed to go at a maximum speed of 100 miles per hour at sea level with the air density of what's given here, and it has a frontal area of 22 square feet and the drag coefficient of 0.34. Given these characteristics, they expect certain performance, and then they realize there is a track to resistance they forgot, and if the car is put in service, the track to resistance is going to take the performance of the car, so they want to do something about the track to resistance. One way to do that is add additional weight to the car so that can take care of the track to resistance. In a formula that every 2 pounds of additional weight of the vehicle is going to give an additional 1 horsepower to overcome the track to resistance. That is what is given to you. Now, the same problem here on your right, you see what is given is the original weight of the vehicle is W sub O, and if you take W as the total weight and WA as the automobile weight, so W is going to be a sum of W sub 0 and let me write it down correctly again. WA is the automobile weight. So WA plus W sub 0 is going to be the total weight W. So frontal area is given, drag coefficient, air density, and maximum speed. So the formula is for every 2 pound additional weight 1 horsepower, or additional horsepower per pound will be WA divided by 2 horsepower. So that is what is given. Let me bring that what we just entered in the previous screen here, WA over 2 HP. And if you want to convert into horsepower into lb feet per second, you multiply this horsepower with 550. WA over 2, so this is equivalent to WA over 2 times 550 lb feet per second. So this, hold on to that one just for a second. Now the grade is not given, so let's take grade is 0. Let's work this out at level ground. So grade will be 0. So the approach is going to be the additional power has to be equated to the power required to overcome the aerodynamic and rolling resistance absent grade resistance, so which we are going to drop this term here. So the power is nothing but resistance times the speed, which is why you see the additional term here. So bring this guy over here. Let's see. Bring that guy over here. Let's enter that. W over 2 550 is going to be times 550 is going to be 225 WA, and I'm going to expand the terms inside and then bring V into insides also. So that's going to be rho over 2 CD drag coefficient, frontal area, and then V cube plus the formula for rolling resistance will be 0.01 times 1 plus V over 147. So multiplied by W, which is the weight of the vehicle, which is total weight, and multiplied by, we are bringing V inside, so multiplied by the velocity or speed V. So this is where W value is going to be W0 plus WA, which is the total weight. So W0 of course is 2500 pounds, and WA is the additional weight we are going to add to the automobile. So let's write down, expand a little bit here. Rho over 2 0.002378 divided by 2 multiplied by CD value of 0.34, 0.34, and AF value is 22, and V cube, remember V is in miles per hour. Rho, forgot this unit here, slugs per cubic feet. So rho is in slugs per cubic feet, and area is in feet square, so you have to convert velocity into feet per second, and the formula is of course from miles per hour to feet per second is 1.47 times 100, and it's raised to the power 3, and now the second term here will be, so 0.01 times 1 plus speed is 1.47 times 100, if I can get it right, divided by 147, and in place of W we're going to write W0 plus WA, which is W0 is 2500 plus WA, and multiplied by another speed term here, which is 1.47 times 100. So that completes the equation. So what you have is one unknown, which is WA here and WA here. That's only one unknown, and you solve for WA, you get WA equals 130.2 pounds. So that means if you add 130 pounds to the car, then your tractive power is taken care of, and that's the problem.